Dear students, in this video, I'd like to show you how to perform analysis of variance using RStudio. We have already covered the theoretical part in the theory class. So today I'm going to explain how we can perform ANOVA using RStudio. If we just recall back the example I have given you in the theory class regarding a researcher wished to try 3 different techniques to lower the blood pressure, and the data given were for the blood pressure among the 3 groups, and we want to test the claim that there is no significant difference among the means of these 3 groups. To apply ANOVA in RStudio, first of all, you need to download the file. So the file name is BP. You will find this file in MS Teams. You can download the file and open the file to see. We have 2 variables here. The first variable is treatment, and the treatment is a categorical variable with 3 categories: medication, exercise, and diet. The second variable is a numerical variable, which is blood pressure. So the code we use to apply ANOVA is AOV. It's a shortcut for analysis of variance. Then first of all, you need to enter the numerical variable. If you see the data frame, the numerical variable name is blood pressure. How do we extract that variable in R? First of all, we need to write the file name, $, select the numerical variable, use tilde. Again, now you have to select the categorical variable. File name, $, categorical variable name is treatment. When you press run, you will get these informations. You will get the sum of the square between the groups and the sum of the square within the group, and the degree of freedom between the groups and the degree of freedom within the group. We need more information because in theory, what you have studied, you need to get the critical value, the test value in order to make the conclusion. So what we will do, in order to get the ANOVA table, as you have done in theory class, we need to write the code summary and put the previous code inside the summary. Run the code. You will get now an ANOVA table. It's now easy to read the ANOVA table. First of all, the first line gives you everything related between the treatment or between the groups, and the second line tells you about within the group. So the degree of freedom between the group, we saw in the theory class, it's equal to 2, and within the group, it was equal to 12. The second column tells you the sum of the square between the group, and this is the second line, the sum of the square within the group. Same thing here. If you just go back to the theory, we found that the variance is equal to 80.07. Where you can get the variance in the output, you will get it under the mean square column. And the first one is for variance between the group. The second one is the variance within the group. How about the test value? If you go back to the test value you have calculated in the theory, it's 9.17. We can get that value in R under the F value column. That is the test value. What about the last column? This is the p-value. So the p-value, normally if we are using p-value method, we compare the p-value with alpha. We have to see the level of significant alpha given in the problem and compare it with the p-value. If the p-value is less than alpha, then we need to reject the null hypothesis. What are the null and alternative hypotheses for ANOVA? Just go back to the theory slide. You will see that the hypothesis for ANOVA, we say that in H0 that all the means are equal among the 3 different treatment, the average blood pressure, we assume they are equal. And in H1, we say at least one of the mean is different. So that is our hypothesis. So based on the hypothesis, p-value is less than alpha. If we compare it with 0.05, we conclude that we have to reject the null hypothesis. If you are using traditional method, then you have to compare the test value with the F value. Well, so first of all, let's answer this question we have here in the R studio. So what is the degree of freedom between the group? Between the group, the degree of freedom we found is 2, I mean. The degree of freedom within the group we found is 12. The variance between the group is 80.07. The variance within the group we found it's 8.73. The test value, you can find it under the column F value, so it's 9.168. The P value is given here, 0.00383. The critical value only, you cannot get it in ANOVA table, but you have to know that as we study in the theory, F distribution is right tail distribution. So when we calculate the critical value of any distribution, we start the command with Q and write the distribution name. So QF is a critical value command for F distribution. Open the colon, bracket I mean, and then you write what do you have in the right side of the F distribution. We have 1 minus alpha. If, for example, in this question, alpha is 0.05, so we write 1 minus 0.05. If you did not mention the degree of freedom, then you will not get the answer. So you have to mention the degree of freedom for the numerator, 2, and for the denominator is equal to 12. Run the code, you get the critical value, it's equal to 3.885294. You can round it to 2 decimal places using the command round. Take your answer and then put comma 2. So the answer is 3.89 as we got it in the theory using the table of F distribution. So if we are using the critical value, then we have to compare the critical with the test. So comparing the critical, the test value is higher than the critical. So in that case, again, we reach to the same conclusion, reject H0. So we have enough evidence that there is a significant difference, or at least one of the mean is different from other means. So that's regarding ANOVA. Thank you for listening and watching. I finish.